blacksmith for today. In this furnace just here I've got 100 ounces of gold heating up. Very shortly that gold will be melting down and I'll cast it into ingot right here. Now while the gold heats up, I'll explain a bit about the job of the industrial blacksmith in the 1860s. We blacksmiths work for a mining company. Most of these companies were chasing this stone. This stuff is gold bearing quartz. Now mining quartz is very, very expensive. Quartz generally occurs in what we call a reef, so it's a vein or a seam running through the solid rock. To mine this, you're going to need a very large labour force of skilled miners, a lot of very expensive equipment, machinery, and quite often a very deep mine as well. Now the mine up the hill here, the Norby North, that goes down 1,100 feet. Our tours only go down to about 110 foot mark, but this is quite a deep mine. There are mines over 3,000 feet deep around this area. Now to make money out of this, you need to raise that stone to the surface, crush the quartz into a very fine sand like such, and that crushing occurs in the battery. The battery is immediately opposite our doors just here. Once the battery's hammered the quartz into sand, that sand is washed out and it is washed over plates and tables where it is mercury. Now mercury is a very unusual metal. It's a liquid at room temperature and it has a very strong chemical affinity to gold. As the gold particles in that sand wash over the mercury plates, gold and the mercury will combine and they form a thick paste that we call amalgam. Now that amalgam will be scraped off these plates, handed over to me, and that's where my job starts. The very first thing that I need to do is get rid of the mercury, and to do that I simply place the amalgam into a cast iron retort. This is a relatively small retort. So once the amalgam's in there, I'll bolt the lid on, place the whole contraption into a fire. And when the temperature in here gets to a little bit over 350 degrees, that mercury will boil, vapour makes its way down the tube, and it leaves the gold behind in the bottom of the retort. A very simple process, one major problem. Now if I allow mercury vapour to escape into the atmosphere, the company loses a very expensive metal. If I inhale that mercury, I will very shortly go insane and die. Now, is anyone here who would be keen to be the industrial blacksmith? There's very much enthusiasm out there for that, Now, to get around this problem, I will simply place one end of the tube into a bucket of water. Now, that water cools and condenses the mercury as the mercury bubbles through. The liquid mercury is recycled back through the battery. We can do that time and time again. Companies save a fortune, and I get to live and work for at least several years before I start going insane. Now, at this point, gold comes out the bottom of that retort as back to where the purity started at. Purity of natural gold. Around here, that's about 94 to 95%. Some of the most pure natural gold. Still got silver, copper, trace elements of various other things in there. I need that gold to be 99.9% pure to sell as bullion, so I'll place the gold into a crucible. Now, these crucibles are made of clay and graphite. I'll add in there a mixture of different chemicals. Keep the whole mass 1,200 degrees Celsius. Now, gold melts at 1,064 degrees. The chemicals that I add in there will oxidise, strip out those impurities as the gold melts. They float to the surface and they form a thick black substance that turns into a glass called slag. So the slag takes the impurities out. I will cast that liquid gold into this mould. That's a cast iron mould, preheated so it doesn't crack. And at that point we should have a nice saleable 100 ounce bullion. I'm just about to pour this gold very shortly, folks. If you would like to take a photo of that, get your cameras ready now because gold pour itself only lasts for a matter of a few seconds. Gold, currently a bright orange liquid, it's heating very rapidly, roughly around 1100 degrees. Very shortly it will turn to a bright yellow white. That's around 1200 degrees and the perfect temperature for. Here we go. So cameras ready? We have beautiful 1200 degree liquid gold right there. Now that is still roughly around 1000 degrees Celsius on the inside of that crucible. exceptionally good conductor of heat. And this gold is very rapidly transferring heat into the cast iron mould. It's dropped down to around 900 degrees. That is already as solid as a rock, just as quickly as that. So there we have one very impressively tasty bar of gold. 900 degrees, you obviously don't want to handle it for quite some time. That's 9 times the boiling point of water. Now a very good way of demonstrating just how hot this gold is without obviously touching it is to use a piece of timber. I have a piece of pine just here, it's just your standard sort of pine you want to build something out of. That is still pretty hot. If you were to touch that piece of gold, if you imagine for a second that that's my finger would be gone like that. That will take about 2 to 2.5 hours to cool, just sitting in the open air. Now I'm sure you folks have a lot to do in the next several hours, and it does get a little bit boring watching gold cool. I'm going to drop the gold in this water bath here. We have it just under the surface of the water. A lot of the heat transfers into the air and into the water, and I should be able to pick that up in about 20 seconds without losing any fingers. So that piece of gold should be quite safe to handle right down there. Transferred the vast majority of its heat into the water. That's dropped down roughly to around room temperature, just as quickly as that. So that's, oh! That's already quite safe to handle right now. There we have 100 troy ounces, 99.9%, 24 karat gold. So the troy ounce is 31.1 grams, somewhat heavier than the normal ounce of 28.4. So you're looking at 3 kilos of gold just here. Now at today's price, in Aussie dollars, that's just a fraction under $150,000 worth of gold. Not bad for a